Good evening, everybody. Welcome to Turfgrass Epistemology. I am TravisShaddox, and I'm so glad you're here this evening. It's Tuesday evening. It's 0 degrees Fahrenheit here in Lexington, Kentucky, like negative 12 or something Celsius, whatever it is. It's really cold. And in fact, it's so cold they close the public schools tomorrow again. So I think next week we'll be back to a normal schedule without having to juggle my kids' schedule and all the stuff I got to do with them. So look forward to next week being normal. We had a good show this morning. Had 30 or 40 people here this morning going over some videos. So that was fun. And tonight we're going to be going over some soil health content. And what I'm going to do is I'm going to provide an overview of soil health. The definition I get, there's not really a good definition, but you'll kind of get my opinion as we go through tonight. But there's not really a clear consensus on what the definition is. But we're going to go over my opinion and my definition of soil health. And we're going to be talking about some soil health indicators or soil health tests or measurements. We have 2 articles. They're both extremely short. I think one of them's 2 pages. The other one might be 3 pages. I can't remember. They're very short. And I wanted to use these 2 articles as just an introduction to the content I'm going to be going over for the next several weeks so that everybody more or less understands some of the indicators that will be measured in future papers. They're going to be identified in these papers tonight. Okay. I'm going to try to get it done in an hour tonight. Good morning, everybody. Andrew and Mike and Chuck and Mark and Ashanti, Rob, Nick, Turf, Nordlunk, everybody's here tonight. Thanks so much. Main J54, Gray Fox. So let's get started. And what I wanted to do first was go to what has slowly sort of become a fairly decent resource for general definitions of terminology or of terms. I wouldn't necessarily rely on it heavily because when some of the content some of the research I produce, it doesn't show up in this system. So it's not exactly always accurate, but it's pretty close. And that is ChatGPT. I asked ChatGPT to provide a definition of soil health. And what it came back with was, a relatively decent, generic sort of, vague definition, which is not too far off from some of the scientific definitions, to be frank. So the definition on ChatGPT is soil health refers to the ability of a soil to function as a living ecosystem that sustains plant, animal, and microbial life. Now, first of all, let me just say this before I get started too much. This is just going to be my opinion on soil health, and I could be wrong on a lot of this. I am a soil scientist, as you know, but so this is sort of in my wheel wagon, if you want to call it that. But so just keep in mind, it's just my opinion, and there's a lot of room for error in the terminology of soil health. Having said that, I'm not overly concerned about the definition of soil health when it includes microbial life. Let me explain what I mean by that. Yes, healthy soils have microbial life, yes. But at the end of the day, what a healthy soil needs to do is produce animals and plants for human beings. Okay, if human beings, presto changeo, were extinct from the earth tomorrow, no one would care about soil health. We need soil health, or we need to be aware of the soil properties as it affects plant life, because that's how we grow our food, and how it affects animal life, because that's how we grow our food. We're not out hunting and gathering like we were 20,000 years ago. Okay, so you talk about microbial life, I mean, it's part of it, but what I care about mostly is what it says here is sustains plant and animal life. I don't really know what the word sustain means in this context, but I'm in agreement with plant and animal life. It involves maintaining the soil's physical, chemical, and biological properties in a way that supports sustainable agricultural production. I don't know what that term means. Sustainable agricultural production. I know what agricultural production means, but I don't know what sustainable agricultural production means. Sustainable in what regard? You just keep farming the same land over and over and over again? Is that sustainable? Is it sustainable in the sense that you don't have to have any inputs into the land, and the land actually provides the resources to grow plants to an acceptable quality without any anthropomorphic input? Would that be sustainable? So you can see right there, we're already talking about content and terminologies that are vague, to say the least. It also promotes biodiversity, enhances water infiltration, and minimizes erosion. I really don't care about any of that unless those variables influence human well-being, plants and animals that affect human well-being. That's what I care about. So do I care about erosion? Yes, because too much erosion can actually reduce plant growth, and that can have a negative impact on human well-being. Do I care about water infiltration? So long as the water infiltration is harming plants and it's having a negative effect on plants, then yes, I do. But these are all sort of indicators. Ultimately, it has to provide a root zone, if you want to call it that allows the plant to reach, or the animal to reach, its potential. That's what it comes down to, and I'll define it here more succinctly in a minute. A healthy soil is rich in organic matter, has a balanced nutrient profile, I don't know what that means, and supports a diverse community of microorganisms that contribute to soil fertility and overall ecosystem resilience. See a lot of sort of word salad a little bit in there, and a lot of vague terminology and amorphous terms, ambiguous terms, ecosystem resilience. How do you measure that? Microorganism community diversity. How do you can measure that, but why is that important? It's important as long as you can connect it indirectly or more preferably directly to plant and animal growth and in turn, human well-being. So, but in general, after I've criticized the heck out of this definition, in general, it kind of gives the average person a sort of a vague idea of what soil health is. Okay, I'm going to give you my definition of soil health. Okay, ready? It's not that complicated. I've said this before. You can probably put 1,000 soil scientists in a room and tell them to come up with a definition of soil health, and they'll probably be in there to the end of time before they can completely 100% agree on what that is. And you'll see that tonight in tonight's paper. You'll see all the soil health indicators, and you'll see what percentage and frequency that those indicators are measured in these soil health publications. And you can clearly see there's no consensus. Okay. So having said all that, my definition of soil health, what is it? If a plant is provided with sufficient water, light, temperature, and there is no injury, biotic or abiotic injury, there's none of those happening. So there's no reductions in the plant's growth potential as a result of any of those variables. All of those are at ideal levels. Water, light, temperature, and injury. All those are at ideal levels. When planted in a soil, if that plant can reach its growth potential without any input, then I would consider that soil to be healthy. Now, I can only think of really one type of soil that would do that, and that is organic soils that have the capacity to mineralize nutrients to a level that meets the plant's demand for those nutrients. Okay, or so organic soils down near like Immokalee in Florida, sort of in the Lake Okeechobee area of Florida, South Florida. There are some soils down there that are organic soils. There's organic soils all over the United States, all over the world, but those types of soils, you don't really have to apply anything to them. You don't really have to water them if they're in tropical or subtropical climates. In other words, if the plant's provided with enough water, they have enough light, the temperature is right, there's no abiotic or biotic injury, then you don't really have to do anything to those plants. The turf grass on those systems on organic soils, you don't have to fertilize. The soil itself provides all the nutrients it needs. So there is no additional human input at that point, and the plant grows to its potential. I would consider that a healthy soil. But that's not that normal. Okay? By that definition that I just gave, the overwhelming majority of soils in the world are not healthy. Why? Because turfgrass isn't going to grow to its potential in most soils unless you add nitrogen or add sulfur or add phosphorus or add potassium or add some element that's deficient. Okay? So that's my definition. Or you can exchange the word plant with animal, like if you're growing hogs or cattle or, sheep or anything like that you're chickens or something like that, something that you're growing animals on, you can just change the word plant with animal, and that'd be the same definition. Can the cow grow to its potential without any additional input from a human based upon the plant's growth on that soil? Assuming that all the other factors are not a problem. The only thing left is the soil. So that's my definition. I don't know if anybody else wants to throw something else out there, but that's my definition. So if you don't have to do anything else to it, that's a healthy soil. If we're constantly trying to add nitrogen to get the plant to grow beyond its capacity in that soil, it's not going to grow to our desired acceptable level unless we add something to it. So I would argue that is, by definition, not a healthy soil. So having said all that, I mean, who cares? I mean, there's plants growing all over the creation. Turfgrass looks great all over creation with just a little bit of inputs. The majority of our situations are going to require a little bit of human input because the soils are not going to provide everything that it needs to reach its potential. We're used to this. This is normal. This is why the Haber-Bosch process exists today still, because plants cannot grow to their potential in the absence of additional nitrogen. The soil will not provide it. Okay. So whether it's healthy or unhealthy, I mean, I guess then you can start to argue and split hairs as to how much human input do you need in order to reach its potential. Then you're just going to start splitting hairs. Okay, well, you got to apply some more nitrogen on this soil than on that soil. You got to apply some phosphorus on this soil than on that soil. Then you're just splitting hairs, and you're trying to not redefine, but further define the definition further down. But anyway, that's my take on it. And we're going to go into a couple articles here that have a different take on it. It's just a more detailed take, and it's fine. But just keep in mind, this is not a consensus, a slam dunk. My definition will be, there's holes in my definition, and there's arguments to be made against it. There's no question about it. Soil scientists who are listening to this right now are thinking that, well, that's way too simplistic, and they could easily and very validly argue against that definition. There's no question. Okay. That's the problem. No one can come up with a clear definition of what it is. But what I would argue, I don't care about that. I care about what it does. And what it does is result in healthy plants and animals that support human well-being. I know that sounds selfish, but that's just who we are as a species. I care about human beings more than I care about a gnat that flew into my window. I care about a human being more than I care about, pets. I mean, if it's the difference between my daughter and my dog, then my daughter wins. So humans generally will take the highest priority. And the same holds true in other species. If you're a chimpanzee, you support other chimpanzees and you will defend your species generally. So anyway, that's my take on it. Enough about my definition. Let's look at a couple of articles and we'll see how far this goes. They're very short. I'm probably going to read most of the article. And let's see, how do I get that up there? Okay, so the title of the first article is, I'm sort of doing this backwards, but I'm doing it kind of backwards for a reason. The first article is Understanding Soil Health Testing. Now, we all know, if you're regular viewers of the channel, you all know my opinion on soil testing. There are valid soil tests and there are invalid soil tests. And I'm not a fan of soil testing just for the sake of soil testing. Do it for a good reason, and the data can be useful to you, assuming you choose the correct valid test. In the world of understanding soil health testing, I hope no one's come across this yet. Okay. I don't know if you have. I mean, if you're willing to speak up in the chat and say, hey, I've come across this and I've used these, or someone wanted to give them to me or whatever, feel free to chime in. But in the case of soil health testing, the confidence is exponentially lower than standard tests. But what I mean by that is, when we interpret standard tests, we have a certain level of confidence. And my confidence on nutrients other than phosphorus and potassium, pH, of course, salinity, of course. But my confidence on these other elements is not very good at all. It's not great on some of the ones I mentioned, phosphorus, potassium, and pH and salinity, but it's good enough. So I don't have a lot of confidence changing stuff around because you took a soil test and your manganese level is 25 or something. You should add more manganese. I don't have a lot of confidence in that. So I definitely don't have a lot of confidence in soil health testing. So if you've come across this, I would just say, just like the flawed, phony ion exchange health soil test, I would say the potential's there to have good information. The potential's there to have a significantly beneficial impact on our industry, but there is not enough data to support them at this point. Okay, so having said all that, and I'm going to show all this in publications, by the way. I'm just introducing it now. So when we talk about understanding soil health testing, we're going to talk about the soil health tests, and then we're going to talk about the components of the tests. But if you come across them, just pump the brakes a little bit before you jump into it and think, oh, I'm going to take a soil health test, and my soil health test number is 80, so I'm good. Or it's 60 and I'm bad, or whatever the case is. I wouldn't worry about that right now, and I'll go into that in the coming weeks. Understanding soil health tests. This is by Nate Dorsey, who is the Crop and Soils Northern Great Plains regional editor. This was published in Crops and Soils magazine in 2019. Interest in soil health has grown significantly across the Northern Great Plains. While there are different approaches to soil health testing, 2 particular tests have become fairly ubiquitous: the Haney test and the Solvita carbon dioxide burst test. I'm going to show those 2 indicators in the next paper I'm going to go over tonight, and you'll see that they're not particularly useful. This article describes those tests, how to collect samples for them, and how resulting soil health scores are calculated and interpreted. That's what's important, is the interpretation. I don't know how in the world they're doing that. Okay, so here we go. In recent years, interest in soil health has grown significantly across the Northern Great Plains, primarily as the result of dedicated efforts of researchers and extension professionals. Although still in its infancy, this increased interest in soil health and sustainable farming has led to more labs offering services for soil health testing. Never underestimate a lab or a commercial product or commercial industry or company to jump on an opportunity, even if there's no evidence to support it. They're going to make that money. And that's what a lot of soil health, these soil test companies have been doing. Oh, we'll do it. We'll offer it. They'll make their money. I don't know how in the world the information is useful to the end user, but they don't care. They're going to do the soil test and take their money. According to Lance Gunderson, director of the soil health and new test development for Ward Laboratories in Kearney, Nebraska, there is no definitive consensus as to what tests should be performed by labs, which can be problematic. You think so? Yeah. Just a little problematic. There's no consensus as to what we should even be doing. So why are we even taking these tests? The guy says there's no consensus. We don't know what we should be doing. I would say that most labs have their own twist, including on the Haney test, he says. Unfortunately, it creates a big problem within the industry because now we're not comparing apples to apples, and we end up trying to reduce variability and interpret data. This lack of standardization can be confusing to farmers and crop consultants, and the menu of soil health tests offered by some labs can be overwhelming. The recommendation I normally make, Gunderson explains, is that once you've developed a relationship with a laboratory, you're better off being consistent and sticking with that lab. That idea comes up, and I kind of halfway agree with it, but it's more for like the methodology. But if you end up taking soil testing, sending it to the same lab over and over and over, but the lab is doing the wrong tests, they're doing an ion exchange test, or they're interpreting your soil test depth at 4 inches when you're taking it at 6 inches and you're not communicating with them, or you're doing it on an acidic soil and they're using an alkaline extract, then you got problems. So I'm okay sticking with the same lab as long as the lab is doing the correct procedures for your soil. Despite the different approaches to soil health testing, two particular tests have become fairly ubiquitous, the Haney test and the Solvita carbon dioxide burst test. Now, what is the Haney test? The lack of visual, you can't see what's on the screen very easily, but it's not what you're looking at. It's actually, this PDF is not very clear. So if you can't read it, I apologize. I'll do my best to read it for you. The Haney test was developed in 2011 by Rick Haney, a soil scientist at the USDA. By Haney's own admission, the test was originally developed as an alternative means to measure nitrogen, phosphorus, and potassium in soils using naturally occurring extractants. The idea was to try and mimic what a root sees in the soil, Haney explains, but now there's quite a bit of interest in using this to determine the impact on soil health. In fact, Haney prefers to call the test the soil health nutrient tool, pointing out that the labs are the ones that began referring to it as the Haney test. The natural extractants used are water and H3A. What is H3A? This is an extractant that was published in a paper by 3 authors, and Haney was one of them. And the other authors also happened to end, their last names started with an H. I can't remember. I'll go over that paper. But it's 3 H's A. That's the extractant. I can go over that. Water is used to measure the amount of soluble organic carbon and nitrogen in the sample, while the H3A extract is used to estimate the amount of nutrients that will become available over the course of a season, such as nitrogen, phosphorus, and potassium. So in that regard, it's similar to like a Malick or an Olson or Gray or something like that. The H3A extract is composed of naturally occurring root exudates, which consist of 3 primary organic acids. It is thought that this extractant better represents the amount of nutrients that plants are able to take from the soil over the course of a season compared with traditional chemistries. It's thought that, now we're going to go into some papers in the coming weeks that compare the Haney test with the Malick 3s and the Malick 1s and so forth when it comes to plant response, and it's not any better. In fact, in some cases, it's worse in terms of its correlation to a plant response. So I'm going to make sure that's clear. I'm going to go over papers that show that the Haney test is probably not as reliable or dependable as the existing Malick 3 tests. And what I mean specifically is the R squared, the regression the regression between soil test extract and the plant response or crop yield or whatever. I guess it's correlation. I always get those confused. But regardless, it's not a wow factor. I'll say that. At best, it's equal to these other tests. At worst, it's much, much worse. The Solvita carbon dioxide burst test, the one-day Solvita carbon dioxide burst test was developed by Will Brinton at Woods End Laboratory in 1994 and is now a commercialized product. The test utilizes paddles coated in carbon dioxide sensitive gel that change color as the gas concentration increases. Our test starts at ambient CO2, Brinton says. If you take a probe and hold it up to the air, it won't change color because it's calibrated to an air concentration of about 400 parts per million. The measurement of carbon dioxide respiration from the soil is directly related to the amount of soil microbes that are present. As living organisms, many soil microbes, such as bacteria and fungi, breathe oxygen to carry out metabolic processes and release carbon dioxide. Because microbes are critical to the health of the soil, such as the formation of soil structure, decomposition and plant residue into organic matter, and mineralization of nutrients, one can infer that the higher the amount of CO2 released from the soil, the more microbes are present and healthier that soil should be. You can infer that, but the data doesn't really show it that much, and we're going to go into that in the coming weeks. So if you come across this Solvita test, you shouldn't have much confidence. You shouldn't probably have confidence that the CO2 number is probably a reliable and repeatable number. That I'm not arguing that. But when you compare that to what a crop would respond to, or the plant would respond to, or the correlation between those, there's not a whole lot there at all. And you'll see a little bit of that, just a tiny smidgen of that in the next paper I'm going to go over tonight. To prepare the Solvita test in the lab, I'm not going to go over this how to prepare it, but basically there's this little pad. It kind of looks like those what do you call them? LED night lights that you plug into a wall, and it's like a flat paddle. It looks almost exactly like that. And you put it in this jar basically, and you seal it, and it equilibrates with the CO2. And you take it out and you put it in an instrument, and it measures the change in color. That's all it does. Okay, they're going to talk about this. This will be a test a little bit more in this paragraph, and then that's it. Although the test was developed at Woods in laboratory, the supplies and lab procedures have been made available to other soil testing laboratories, and the simplified kit is also available under the Solvita name. So you can get it if you want to. I wouldn't do it, but so be it. So sampling for soil health. The Haney and Solvita tests have been designed so there is no significant departure from the standard soil sampling procedure. It is recommended that using a soil probe 12 to 15 cores, the same thing as you'd always do. Take a sample, put it in a bucket, mix it up. One common practice in soil sampling, especially in high clay soil content, is to use lubricants on the probe to make removal samples easier. Don't do that. I'm going to skip down to the next one. All right, so they're just talking about living organisms. You take a sample, you don't want to stick it in like a Ziploc bag and kill all the bugs in the soil. That's obvious. So you can't treat it like a normal soil test in that regard. Let's see. Yeah, so they just talks about how to take the test here. So calculating and interpreting the soil health score. Both the values of the Solvita test and the results from the Haney extraction method are used to calculate a soil health score using this equation. The result is a value typically within the range of 1 to 50, with values between 0 and 9 considered poor, 10 to 20 medium, 20 to 30 good, and 30 to 50 very good. That's where my criticism peaks because of that interpretation. So let's say it's 30 to 50 very good. What does that mean? Who cares? If you're going to tell me that a 50, I don't have to do anything other than maintain the water light temperature and be aware of bugs and diseases, then I'll care about it. If you're going to tell me, well, it's very good and you still have to apply nitrogen, well, then what do I care? I'm going to have to apply nitrogen anyway. So that's what I'm saying. These interpretations are where this whole Potemkin village falls apart. I mean, it just, I don't know. And that's the same holds true with regular soil tests. It's not just specific to this type of soil test. A common question about the test is how to interpret the results, such as whether the score is good or bad for a given soil region or set of practices. Yeah. Haney has a simple recommendation to address this. And this is what I hear a lot of. Take the test from a good area, take the test from a bad area, and see if they differ. Okay, well, let's say they differ. So what? Maybe it differs in your area because you've been fertilizing it. Maybe because you've been aerifying it, or maybe even because I'm applying nitrogen, maybe because the grass is growing more and there's more root exudates in that soil. So maybe it's healthier because of that, or maybe the boundary is more healthy. In other words, I don't fully buy into this. Take a soil health test and do a bad area and then do a good area and just compare the two. One, it's just one number. Who cares? Okay, but we need more information than that than just fly through the turfgrass space on a whim, just by comparing it, what looks good, and then take a soil sample from one location that doesn't, or outside of the area that you're treating. And doing that, we need to give ourselves more respect than that, and figure out exactly if these are useful or not by conducting real research. Some of the most common recommended practices for improving soil health include cover crops. We're going to talk about cover crops in detail in the next paper. Diverse rotations, reduce tillage, and reduce erosion, all of which naturally tend to occur on fence rows. Sampling in these areas where soils, okay, talking about sampling those soils. While soil health may seem like the latest buzzword and trend in the industry, it is likely here to stay. Many farmers have implemented practices over the years, such as conservation tillage, that are now known to have positive effects on soil health. And we're going to talk about that in the next paper, whether or not that's accurate or not. Soil health testing and services offered by many labs could be a useful tool for quantifying the effects of such practices on soil health and potentially lead to a better understanding of soil health processes. It could, or it could not. Maybe it does, or maybe it doesn't. Okay, I'm not saying it does. I'm not saying it doesn't. I'm saying I'm not convinced that it does because I haven't seen any data to convince me that it does. So now let's go to the next paper, which is much more detailed, and it's only 3 pages, I think, 3 or 4 pages. So we got time. So before I go into this, let me check out the chat real quick before I go into this and see if there's anything that I need to go over. Yeah. Chuck Benzing's, you like my t-shirt? Yeah, I got some I got this t-shirt. This is the t-shirt that's misprinted, by the way. On the back of it, there's a misprint. So I'm keeping it just because it's so comfortable, but on the back of it, there's a misprint. This has the BS criteria on the back, or the BS, what is it called? The BS cycle on the. So it has the scientific method where there's a misprint and the BS cycle on the back of it. So I'll probably get another one that's printed correctly so I can actually wear it outside. Oh yeah, Mike says hit the like button. Yeah, please hit the like button and subscribe. And if you hit the bell icon, that'll help out a lot too. I always like it when you guys remind me to do that. Main J54 says, growing up in Chicago in the 50s and 60s, we never fertilized our lawns and had healthy lawns. Yeah. I don't doubt it. Like I said, I did my graduate student in South Florida. We were measuring turfgrass growth and how much nitrogen was required on these organic soils, and we found there was almost zero. So these sandy soils down in South Florida, in their summit locations, there's great amounts of organic material in some of them. Those are pretty healthy from my perspective because the amount of nitrogen we needed to apply wasn't zero, but it was extremely close to zero. So to me, that seems to be a good definition of a healthy soil when I don't have to do anything to it and it grows to its potential. Okay, so yeah, okay, all right, guys, let's get into the next article. Okay, so the next article is more of a traditional scientific article. This one's called What We Talk About When We Talk About Soil Health by Ryan Stewart and several other people who I do not know. I don't know where these people are from. But Virginia. They're at Virginia Tech, it looks like. So this is now if you go way back, like a year and a half ago, you'll see an episode where I had my wife on and we were talking about the hierarchy of evidence. And in that hierarchy, we talked about meta-analysis. We talked about what sort of confidence you should have in the information in some articles. And you publish an article and it goes up from rumors and hearsay to evidence. And then you can do systematic reviews and so forth. And meta-analysis is at the very top of that list. Now, this is, no offense to these authors, it's the best analysis I know of on soil health so far, but it's not the same type of meta-analysis you might see in a top-tier journal. Okay, this is in Agriculture and Environmental Letters, which is not a top-tier journal. I think I have one article in there maybe, but it's not a top-tier journal. And this article is a meta-analysis, so it should be received as greater. You should have greater confidence in the information in here than just any one single article. But it's not particularly robust in the meta-analysis world, okay? So let me get into this, and I'm probably going to have to read most of it. As you can see, it's 1, 2, 3.5 pages, and some of it's just pictures. So in what we talk about when we talk about soil health, okay, as the International Decade of Soils draws to a midpoint, the importance of soils is being recognized. From mainstream media articles to global climate modeling efforts, conservation agencies such as the USDA Natural Resource Conservation Services have made soil health, the maintenance of soil ecology and properties aimed at sustaining plants, animals, and humans, a primary focus of outreach and research efforts. Now, this is really more along my speed, sustaining plants, animals, and humans. Okay, that's what I like. I don't know what the word sustain means in their world. They have to define what they mean by sustain, but I'm in agreement with that. Enterprises such as the Soil Health Partnership and Soil Health Institute have emerged from this renewed focus on soil management and quality. At the university level, initiatives such as the Cornell Comprehensive Assessment of Soil Health have focused on the collection of soil health measurements. These entities support widespread implementation and research activities with the goal of improving soil health across the United States and around the world. Despite building on decades of prior inquiry, research efforts on quantifying and interpreting parameters that would define soil health often take a scattershot approach, with each study focused on a handful of indicators and how they respond to one or two interventions. Such haphazard approaches have led to equivocal conclusions. For example, no-till sometimes enhances infiltration, yet sometimes it doesn't. There is also increasing concern that many current soil health metrics lack sufficient sensitivity to resolve differences from management practices, and that certain indicators have excessive interlaboratory variability. So basically they're saying it's the wild, wild west in the world of soil health measurements. That's what that paragraph says. We don't know who's doing what. We don't know if they're doing it correctly. If they are doing it correctly, we don't know if there's enough sensitivity in their analysis to actually have any meaningful results. It's literally the United States in like the 1850s and 1880s, 1890s. It's the wild, wild west. We don't know. Okay. That's what this paper is going to help to kind of define and orient some of the scientists more in line with each other, I hope. In response, efforts are underway to standardize and compile soil health studies. The Soil Health Institute has endorsed 19 Tier 1 indicators, which, by the way, I do not agree with. The Soil Health Institute has endorsed 19 Tier 1 indicators. Those are indicators 1 through 19. I'll figure out. I'm going to show those. So, and that includes some, but not all of the measurements provided by the USDA and the NRCS, Soil Quality Test Kit. So I'm going to show all these down here. You're going to see real quick why I do not agree with that. Some of what was endorsed. And this is what I'm saying. You put all this in a room and you say you must universally agree with everything. You're never going to get that from soil scientists. You're never going to get a complete consensus of soil health. So that's the reason I just don't like the term. I am 100% in agreement with the soil health indicators. Let's talk about texture. We can talk about structure. We can talk about nutrients and fertility. We can talk about saturated hydraulic connectivity. We can talk about a lot of these things. But you want to say, I need to have better healthy soil. I'm like, what does that mean? We can't define it. And I'm going to show you exactly why I am in disagreement with at least one of those 19 Tier 1 indicators. Notable omissions to these indicators include soil respiration, slaking, and earthworm tests. The Tier 1 list also does not include any biological components. The Soil Health Institute instead relegating indicators such as beta-glucosidase, whatever that is, to Tier 2 status. The soil health indicators and methods to be assessed. So Tier 1 is, they're going to label that as really like the main variables, and then Tier 2 are yet to be assessed or methods that need to be assessed. This apparent lag in incorporating biological indicators into soil health assessments highlights the need for the soil health community to focus on evaluating and refining these metrics. Yeah, no S. What blows me away is there's so much interest in revenue and resources, money being thrown at this, when we can't even agree on what it is as scientists. There's a saying in sales. I don't know if it comes from, I forget what book it comes from. But the saying is, don't manage what you can't measure. So we can't even measure soil health. So why are we trying to manage it? We can measure the indicators of soil health, and we can manage those, or we can manage practices to move them in whatever direction you so desire. But just to say soil health, that's just a big black box in my opinion. Now here's what I'm talking about. Oh, let me finish this section, then I'll go to the figure up there. To avoid such an outcome, our purposes here is to provide a survey of what is currently measured related to soil health, discuss how method standardization could be improved, and consider how a common framework could advance the science and practice of soil health. Okay, what did we measure when we measure soil health? The NRCS lists 4 soil health planning principles: minimizing disturbance, maximizing biodiversity, maximizing soil cover, and maximizing living roots. Now, name me any species of plant other than POA, so the grasses, Poaceae, family Poaceae, so let's say family of plants, that is better at that than grasses. Minimizing disturbance. If you're not aerifying and verticutting, you just have a lawn, you're not really disturbing the soil. And this is one reason why I'm saying I'm not in favor of aerifying unless you need to, unless you have a good reason. Maximizing biodiversity. There are so many freaking microflora and microfauna and macroflora and macrofauna out in my yard in most people's lawns. It's crazy. Maximizing biodiversity, maximizing soil cover. I would argue there's not a plant on the planet that is better at that than grasses. And maximizing living roots. I don't know what they mean by maximizing, whether it's like the total number of roots or the total mass of roots or the length of roots. I don't know what they mean by that, but you're not going to have a plant, at least not that I'm aware of, that's going to have more roots in the top 6 inches than grasses. It's just not going to happen. You have a carpet of a living organism that minimizes disturbance, maximizes biodiversity, and maximizes soil cover and maximizes living rate, probably compared to virtually any other plant on the planet. So the turf grass itself is probably helping develop, quote unquote, healthy soils. Okay. That's for all my environmental, combatants and opponents out there that want to argue that turf grass is evil. It's not. These principles inform the 4 main actions of the Soil Health Institute Research Landscape Tool. Therefore, we compiled all papers listed in the Soil Health Institute under residue and tillage management, no-till, and cover crop. Altogether, we found 106 peer-reviewed studies listed under no-till and 86 under cover crops, totaling 192 unique peer-reviewed studies. We recorded all metadata and the type and number of soil health measurements reported. Remember, meta-analysis is taking in data from a number of other publications and other projects and amassing them into a single paper and then running data on that. That's a meta-analysis. That's the reason meta-analysis we have more confidence in meta-analysis than we do any other single paper. Okay. The 192 studies occurred throughout North America, although most, greater than 70%, were located in the South and Midwest census region of the United States, and you'll see that here. Most of these, of course, this is the farm belt or the bread basket of the United States here, and that's where a lot of the projects were conducted. You're not going to have a lot out here in the deserts, obviously. Okay, so that's where the majority of the data were pulled. The studies were conducted and the data were pulled from those areas. Now, I'm not going to go, well, let me read the next sentence. As detailed in the supplemental material, the earliest study occurred in 1943 and the most recent occurred in 2015. Okay, so let me go up here and show everything that they measured. I know it's going to be difficult to read this. I'm going to try to zoom in as best I can on this figure because it's not the video that you're watching. It's the actual PDF is really poor quality. I don't know why. So we're looking at a figure that has on the y-axis the proportion of the studies. So all the studies that these investigators pulled, and so that's the percentage of, or the proportion of the studies. And then on the x-axis we have the number of indicators. Okay. Now, there are things like soil carbon, soil pH, aggregation, crop yield, texture, penetration, CEC, electrical conductivity, these things. And it goes all the way from 1 to 42. Okay? Now, the first 19 are the tier 1 measured one, or the endorsed ones, the variables that were endorsed, or the indicators that were endorsed by the Soil Health Institute, I guess is what it was. And you're going to see real quickly why you'll never get soil scientists to completely agree. Maybe they endorse this, but I don't know how many people were on that committee. It'd be difficult for me to be convinced that all of them agreed to these 19. So number 1 is soil carbon. And these are not in any particular order. They're just listed this way. Soil carbon, pH, aggregation, crop yield, texture, penetration, cation exchange capacity, salinity, soil nitrogen, soil pH, soil potassium, is this carbon mineralization? What's 12? Mineralizable carbon, yeah. So mineralizable carbon, mineralizable nitrogen, erosion, BS, and then bulk density, available water holding capacity, infiltration, and micronutrients. Those are the indicators that this committee agreed should be tier 1 indicators of soil health. What is BS? No, any jokes, you can just put them in the comments. BS is base cation saturation. And you'll see it's the lowest used, less than probably 2% of the studies included BS, base saturation, in their studies. And the committee endorsed that. And I have shown, I don't know how many papers. Someone can go back and look at it. Dozens of papers indicating why base kind of saturation is BS and it shouldn't be used. And yet somehow the soil health whoever did this, soil health company or whatever, what the hell's the name of it? Soil health, whatever, endorsed it. Shouldn't be endorsed. I would have been there filibustering that committee until I passed out to keep that from being on that list. And why? It's real simple. None of the evidence supports it, and all the known evidence refutes it. It's that simple. So why is it on there? So this is an example of even the brightest among us, or the committees among us, doesn't mean they're right. Okay, it doesn't mean they're right just because they come up with a list. It could be incorrect. But other ones are things like KSAT. KSAT is far more valuable to me and to you than BS. And it's not a tier one indicator. KSAT gives us a number on the percolation of water through the soil, saturated hydraulic conductivity, immensely important. It's not on there. Porosities, it's on the list, but it's not a tier one indicator. And porosities, not a tier one indicator, also very important. Soil water content, very important. So these are all water related, and they're not even in the tier one indicator. So like I said, you can put all of them in the room and you're never going to have everybody agree on everything. I get that. But to have BS on there and not to have KSAT on there blows my mind. But look at the carbon burst down here, number 36. It's not on there either. And that's the Solvita technology, basically. It's measuring carbon dioxide burst from the soil. And it's not considered a tier one indicator, but yet that test is used to give a soil health test by many soil testing laboratories. Okay, so those are some of the indicators. That figure are all the indicators basically that you can come up with, for the most part, that can be used to assess soil health. With the exception of BS here, I'm okay with pretty much measuring any of these. Diseases and weeds and pests and runoff, and I'm okay measuring any of these and changing management practices and developing best management practices to adjust these indicators one way or the other to maximize our potential in plant growth, animal growth, and so forth. I'm okay with that. But if you're going to come up with some model that takes all of these into account and then gives me a number, I'm not saying it can't be done. I'm saying the opposite. I'm saying if you're going to come up with a soil health number, you better figure out some way to model all of these indicators, come up with a number, then go out and run a correlation on that soil with that number and see what the plant response is to whatever plant growth potential, I guess it would be, or the animal growth potential would be on a soil with that soil health test number. And then do it on another soil that has a different soil health test score and so forth, and determine whether or not there's any relationship between that test number that you're going to come up with and a plant or animal potential growth. If you can do that, I'm all for that. Now, I'm also all for somebody paying a boatload of money for people to go out and measure all 19 of these variables. That is not cheap. The reason why the most common one was soil texture, and at 80%. And look at the one crop yield. It's only 30%. The one variable that matters is crop yield, and only 30% of the studies that measured soil health, you measured that. So, I'm all for measuring these. It's fine, but you got to pay for it. Somebody's going to have to write a massive check if you're going to just say these are the 19 soil health indicators that we're going to measure, because I don't know of many programs in the United States that have enough money to measure all this stuff. You're going to go out and do a correlation between a 19 soil health indicators and crop yield or plant growth potential or animal growth potential, whatever it is. That is expensive. So there has to be some sort of practical realization that you're not going to have scientists do all this stuff. And that's the reason why you only have 30% of the studies using these variables, 20% using those variables, because we're not sitting in a pool full of cash. We can only do what we have the resources to do. This is real stuff that requires real money, real analysis, and it's not cheap. It's usually a lot of labor, bulk density. If you're going to measure bulk density correctly, that takes a grad student or a technician a lot of time to do that. Okay? Texture, you're going to measure texture on every single soil, or are you going to pull it from a book? If you're going to measure it on every single soil, that's labor intensive. Okay? So I don't fault these studies for only having 25% of the studies only 25% reported pH. Only 25% reported aggregation, soil aggregation. Very few. All these are very, very low. And that's what I would expect to see. So write a big fat check and give these soil scientists enough resources to go out there and do this work. And we'd love to do this work. But someone's got to pay the bill. We continue. Okay. So basically what this paragraph says here is this summarizes the table that I just showed. And there's a lot of variabilities between what studies are measuring what. And it says these results signify substantial variation in sampling protocols for assessing soil health. No one's doing all the same stuff. There's no agreeable measurements, no agreeable indicators. And then they go on to say, we grouped all measurements into 42 indicators, of which only 8 were reported in more than 20% of the studies. Only 8 of the 42 were reported in 20% or more of the studies. Crop yield, despite being of paramount interest to farmers, so that'd be the equivalent of turfgrass quality, or turfgrass yield, I guess, was recorded in less than 1/3 of all studies. The one thing that matters, cattle growth, hog weight, whatever. I mean, something that matters to humans. The one thing that matters, only a third of the studies actually reported it. So here we go. We also analyze the responsiveness of each indicator to cover crops. And we hear a lot about cover crops and how including cover crop will increase soil health and I'll have all these benefits. And it's possible. But what they say here is after 1 year, 13 of the 42 indicators showed a 10% relative change. After 2 to 3 years, 10 of the 42 indicators showed more than a 10% relative change. The remaining indicators either had negligible responses or lacked sufficient observations. So what I mean by that is, in this figure here, I'll zoom back in where we're looking at a new figure here, guys and gals. And on the y-axis, we have t-test mean and 95% confidence intervals. And on the x-axis, we have the various variables, the indicators that actually influenced or were influenced by cover crop. And the way to read this is, this variable here, erosion, showed a reduction in there was a reduction in erosion as a result of applying cover crops compared to not applying cover crops. There was a reduction in runoff. There was a reduction in leaching, weeds, and diseases. And there was a slight increase in aggregation, mineralizable nitrogen, not much at all, but a little bit, infiltration, diseases, pests, fungal, enzymes, and some of these other things. So there's actually an increase in things that we wouldn't want, like an increase in pests. Okay. And then in year 2 and 3, we saw even fewer indicators have an influence. But again, with cover crops, it reduced runoff, it reduced leaching, it reduced weeds, and it increased slight increases in aggregation in mineralizable nitrogen. So that's how to read this if you want to go through and read that. So there was a little bit of an influence on cover crops. Sometimes it was beneficial. Most of the time it was beneficial. Or when it was influential, it was mostly beneficial. There were sometimes it was negative. But so there was, 10 or 12, whatever there was. The other 30 had no influence on it at all. Cover crops did not influence, for example, base saturation. Didn't influence KSAT or enzymes or carbon burst. Didn't influence that at all. Okay. Now we're going to go to what should we measure when we measure soil health? So that's what they did measure. What should we measure? The 42 indicators can be grouped into 6 categories: physical properties, chemical properties, biological indicators, environmental states and fluxes, agronomic responses, and general indicators. The most responsive indicator mainly fell within the biological, environmental, and agronomic groups. Even though we classified aggregation as a physical indicator, biological activity influences aggregation, formation, and stability. Infiltration, another physical indicator, showed high responsiveness, even though the related indicator which is saturated hydraulic conductivity, did not, suggesting uncertainty in how cover crop enhanced infiltration rates. And we're going to the very last part here. Management decision making can also be enhanced by considering soil health in both absolute and relative terms. Good soil health depends on a combination of location and management. In an analogy to human health, a doctor might measure the same vital signs on all patients, yet only prescribe interventions based on individual characteristics and risks. So again, how the heck are you going to recommend to do something if you use an example saying, well, doctors will measure the exact same thing on human subject A through Z, but he'll only recommend prescribing certain, procedures on some people, even though the measurements are all identical across all people. Okay, and that's true. They do that. So how are you going to do that in soils? Collecting the vital signs of different soils can help agencies and producers prioritize efforts on soils that are truly unhealthy, and can also help track the relative progression of a given soil from baseline toward goal. Vital signs can also be used to assess risk factors to soils based on their individual characteristics, which can help predict resilience to impacts such as drought or extreme temperatures. Having a standardized set of protocols and indicators can therefore allow the community to better strategize and prioritize efforts to improve soil health across diverse systems. And the last little part, I'm just going to read in orange and red. We contend that soil health methods and metrics must be verified by land-grant universities and other entities to ensure adequate peer review and testing is completed before dissemination to networks, extension agents, agencies, farmers, and other stakeholders. I can give two flips about peer review. I don't care about peer review hardly at all. What I care about is refereed papers. Refereed papers are peer-reviewed, but not all peer-reviewed papers are refereed. And what the difference is peer-reviewed papers can go out through universities, and they're reviewed by internal peers, but they're not refereed, meaning that they don't have any chance of being rejected. And oftentimes publications will go out through universities that are peer-reviewed but are flawed, greatly flawed, and oftentimes skewed if the faculty member happens to get off in left field somewhere and have an agenda. Their information can go out through the university and still be incorrect. But refereed papers are oftentimes double-blind reviews, and the criteria, the review process is much more stringent. I really don't care about peer-reviewed papers. I care about refereed papers. Anyway, we recommend that all studies provide soil texture, pH, bulk density, and soil carbon, thus providing a basic set of soil vital signs. So if you're going to do any work, guys and gals, and you're going to be working in soils, bare minimum, provide the soil texture. Or if you can, provide the sand, silt, and clay percentages. That's what they say they actually prefer. And all that's fairly easy. Just get a nest of sieves and you do it. You can do the hydrometer method if you want, which is more accurate, I guess. But get soil texture. pH, fairly simple. Bulk density, it's simple, just requires a little time. And soil carbon, which is easy nowadays with our combustion instruments we have. We can at least do that. So that's what they're recommending. At least do that. We also suggest, based on data compiled here, that studies should focus on measuring responsive parameters such as aggregate stability, infiltration rates, or preferably KSAT, saturated hydraulic conductivity, and microbial indicators such as enzymatic assays and biomass nitrogen and carbon. Finally, a common framework should be inclusive. Here's an important paragraph right here, guys. I don't know how they got this in here, but I'm glad they did. Finally, a common framework should be inclusive of all measured data, not just those results deemed significant. That's a great line. It's fantastic. And I think the reason I say I don't know how they got that through there, because oftentimes editors and reviewers can kind of get annoyed and offended by that. But occasionally reviewers and editors will kick back something because there wasn't any significance. That doesn't make any difference. If the study was conducted correctly, according to the standard procedures for that industry and for that discipline, you shouldn't care what the results are. As long as it's valid, there should be no rejection of data or of a paper simply because the data was whatever the data was. There should be rejection of the paper if there was a fatal flaw in the methods. No question about that, for sure. If there was a known bias or some flaw that was valid, then sure, no problem. But it's just because the data isn't what you think it should be or it shows no significance. I never have understood that. And I'm glad they got that in here. Let the papers through as long as they're corrected, as long as they're correct, as long as their methodology is correct, as long as the conclusions are within the boundaries of the results and so forth. By including negative results in which treatment differences are not detected alongside positive results in which they are, the soil health community will finally be able to talk about soil health in a consistent and transparent way. So what that means is if you go pull 40 papers on, pick a topic of nitrogen applications or iron applications or whatever, you're generally going to find papers that showed a difference. There's not going to be a whole lot of papers that show nothing happened. Well, nitrogen is not a good example because you're going to have results almost all the time with nitrogen, but you know what I mean? You're not going to find a whole lot of papers that said nothing happened. You'll see that in my iron solubility paper because nothing happened. So let those papers, so it does happen, but let those papers through. Rejection of a paper based upon the results is not a valid point to reject it as long as the results are correct in terms of its methodology and conclusions are within those bounds of the results. Okay? But that's called publication bias. And what they're saying here is not just those results deemed significant, include the negative results too. And oftentimes we don't include negative results in papers, and that is the definition of publication bias. I don't care what the results are. Neither should you. You couldn't care less what the results are. I just care that they're valid and they're correct. And if we don't understand it, our responsibility is to redefine the model, redesign the model. The reality is not going to change. So if the model says this and some data comes in that refutes it or contradicts it, we can't change the reality. We have to figure out our model. We have to adjust the model so that it fits, right? And oftentimes I've always wondered whether or not the negative results get kicked back because there's some, I don't know, editing or reviewer bias against negative data. What they perceive as negative data, I perceive it as data. It's just data. Okay? That's all I got, guys. I don't see any other comments in the chat. I will be working on some creative content. I'm not entirely sure if I can get it done by next Tuesday. I was going to try to get it done by this Tuesday, but I ran into some hangups. So I'm working on a kid's book, if you want to know what I'm doing. And it has to do with turfgrass. I'm having a little bit of difficulty getting through it, but when I do, I'll show it on the channel, and we'll go through that on the kids book on the channel. And if I ever do get it finished, so that's all I got, guys. I really appreciate everybody's contribution. I appreciate the super chats earlier today. They have some super chats earlier in the episode, in the show earlier this morning. Thanks so much for that. Turf Nerd Lawn Care. I think it was Lush who donated. Thanks so much. And I will let you all go. I'll be back. I think everything will be normal next week. So I'll be back on Monday morning for the members only show at 9 a.m. or 10 a.m. Central on Monday morning. And the Tuesday morning show is always hit or miss. You never can rely upon Tuesday morning, but for sure, Monday morning and Tuesday evening. Thanks, guys and gals. I appreciate everybody being here tonight. Have a good week.